Okay, I'm working these homework solutions for 8.3 trigonometric equations. So the first question is just to make sure we can solve a quadratic equation, and that's just because later on we're going to need to be able to do that. So we take 3x squared minus 5x minus 2, and I'm going to try and factor this. So let's see, if I put 3x here and x here, that'll give me my 3x squared. I need a negative 5x in the middle. So I'm going to do a negative 2 here to give me negative 6x, and that will require plus 1 here for 1x. That would be negative 5x if I put those together. And then if I multiply 1 times negative 2, I get negative 2 at the end. So that should work. And I set each one of these equal to 0. And I get x is negative 1/3, subtracting 1, dividing by 3, and then just adding 2 there. So we should get 2 answers here, negative 1/3 and 2. All right, next question. All right, so same thing, we want to be able to solve this. 6x plus 7, that quantity squared, minus 3 times 6x plus 7, that quantity minus 10 equals 0. So this is where we kind of say, all right, this right here is, I don't know, like a u maybe, and then this right here is u again. So this looks like u squared minus 3 times u minus 10 equals 0. I can factor that quadratic as u, let me see here. I need negative 3 in the middle. I need negative 10 at the end. So how about we go negative 5 and positive 2. That should work. So that means if I set each of those equal to 0, I get 2 solutions, negative 2 and 5. And now at this point, we replace u with what it was. So 6x plus 7 must be negative 2, and 6x plus 7 must be 5. And we subtract 7 on both sides, I get negative 9. Divide by 6, I get negative, let's see, 3/2 if I reduce the fraction. Here we subtract 7 on both sides, I get negative 2. And then divide by 6 and reduce the fraction, I should get negative 1/3. Negative 3/2. I put a comma there, comma, okay, and then negative 1 divided by 3. Uh-oh. All right, now finally getting some trig stuff. So we want to solve this equation in the interval 0 to 2 pi. So we have 2 sine theta plus 4 equals 3. This looks like a linear equation, so I'm just going to subtract 4 on both sides. I get negative 1. I'm going to divide both sides by 2. I get negative 1/2. Now, because my argument is just theta, whatever answers I get, I don't have to get a general solution, because I know that whatever answers I get on my unit circle are the only answers that are going to work. So where is the y coordinate? Because it's sine. Where's the y coordinate? Negative 1/2. It's going to happen here, and it's going to happen here. So this is going to be 11 pi over 6, and then this right here is 7 pi over 6. 7 pi over 6, comma 11 pi over 6. There we go. Okay, same sort of question. We have 2 secant theta plus 2 equals 6. Didn't do a secant in class, but this does look linear. Subtract 2 on both sides. Divide by 2. And so we want to know where secant theta is 2, but that's the same as saying where is cosine theta, the reciprocal of 2, which is 1/2. And again, because the argument is theta, I'm only going to look on the unit circle. I don't need a general solution. So cosine is the x coordinate. That should happen here and here. So that's going to be pi over 3, this angle. This should be 5 pi over 3. Oh. Pi over 3, 5 pi over 3. All right, next one. Solve this one. 2 square root of 2 cosine of theta plus 3 equals 5. Okay, it's looking linear, so I'm going to just subtract 3 on both sides, and then I'm going to divide both sides by 2 root 2, and then the 2's cancel, and I get 1 over root 2. And that doesn't look like one of our common numbers, but if I rationalize, if I multiply top and bottom by root 2, then I will get root 2 over root 2 times root 2 is 2. So that one looks like it's on the unit circle. And again, because the argument is just theta, I'm just going to look on the unit circle. Where's the x coordinate root 2 over 2? It's going to happen here. It's going to happen here. So that's the angle pi over 4. And this is 7 pi over 4. Pi over 4. 7 pi over 4. So when your argument is just theta, you don't have to do the general solutions, which is nice. All right, so now we need 4 cosine squared theta equals 1. Okay, I'll divide both sides by 4. Okay, oops, not 4, 1/4. Something on my screen here. Okay, got it. Now I'm going to take square root on both sides. So when I do the square root on the left, I get just cosine theta. And when I do the square root on the right, I get plus or minus square root of 1/4. And that's plus or minus, take square root of the top, I get 1, square root of the bottom, I get 2. So I want to know where the x coordinate is positive or negative 1/2. And again, my argument is just theta, so I'm just going to look at this unit circle. X is going to be positive or negative 1/2. So that would happen here, 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 or here. So this is pi over 3. This is 2 pi over 3. This is 4 pi over 3. This is 5 pi over 3. All right, so 2 pi over 3, comma, pi over 3. Pi over 3. 4 pi over 3. 5 pi over 3. All right, finally, we have one that has an argument that's not just theta, but they still want the answers between 0 and 2 pi. So where is the x coordinate 1 on the unit circle? Well, that's going to happen. X coordinate being 1 is here, and that angle is 0, right? So the way I'm going to do this is I'm going to get a general solution first. I can be at the angle 0, or I can add full revolutions. So my argument must be equal to 0 plus any full revolution. And that means 3 theta must be equal to 2 pi k. And now if I divide by 3, I get 2 pi k over 3. And now let's just try some values of k. If k is 0, I get theta is 0. If I have k is 1, I get 2 pi over 3, which is smaller than 2 pi. If k is 2, I get, let's see, 2 plugs in there, and I get 4 pi over 3. That's still, 4 over 3 is still smaller than 2, so keep going. If I plug in 3, I get 6 pi over 3, which is actually 2 pi. Now, notice on the inequality, it's 0 less than or equal to theta less than 2 pi. So they're saying specifically we have to be smaller than 2 pi. So we don't want that answer. We want that one, we want that one, we want that one. And if k is -1, if we plug that in, we get negative 2 pi over 3. And that's a negative answer, and we're supposed to be greater than 0, so it can't be that. So it looks like we only have 3 answers here. It's going to be 0. It'll be 2 pi over 3 and 4 pi over 3. All right. All right, so another one where we have something other than theta in here. Secant of 3 theta over 2 equals 2. All right, so this is the same as saying where is cosine of 3 theta over 2 equal to a half, because cosine is the reciprocal of secant. And so I'm looking here, where is cosine a half? So where's the x coordinate 1/2? That's here and also here. So we have 2 different solutions. They're not directly across from one another, and our argument is not theta. So I'm gonna have to get some general solutions here. I need that 3 theta over 2. I need that. Let's do the first one here. The first one is gonna be pi over 3 plus 2 pi k. And then the other one is going to be 3 theta over 2 has to be equal to the other solution here, which is 5 pi over 3 plus 2 pi k. All right, so I'm supposed to get a common denominator, but I'm first going to get theta by itself. So on this first one, I'm going to multiply both sides by 2. If I multiply by 2 on the first fraction, I get 2 pi over 3. And if I multiply 2 on the second fraction, I get 4 pi k. If I divide by 3 now, I'm going to get 2 pi over 9 plus 4 pi k over 3. And now I can get a common denominator by multiplying the top and bottom of this fraction by 3. So I get 2 pi plus, let's see, 3 times 4 is going to be 12 pi k over the common denominator, which is 9. Okay, that's one of my general solutions. The other one, same story, multiply both sides by 2, and I get 10 pi over 3 plus 4 pi k. Divide both sides by 3, I get 10 pi over 9 plus 4 pi k over 3. Multiply the second fraction here by 3 over 3. So we get 10 pi plus 12 pi k over the common denominator, which is 9. All right, now we want only the answers between 0 and 2 pi. So let's just start plugging in some values. If k is 0, see, into this one, we just get 2 pi over 9. And on the other one, if k is 0, we get 10 pi over 9. Both of those are smaller than 2 pi. Now, if k is 1, let's see, we get 12 pi plus 2 pi. That's 14 pi over 9. And 14 over 9 is still smaller than 2, so I keep going. If I plug in 1 here, I get 22. Yeah, 22 pi over 9. And let's see, 9 goes into 22 more than twice, so I'm not going to have that answer, but this one is okay. And so now I can just check k is -1. And if you check k is -1, you're going to get a negative here and a negative here, so it's not going to work. So I should only have these 3 answers right there. And let me try it. So 2 pi over 9. Comma 10 pi over 9, comma 14 pi over 9. That is it. All right, another one where our argument is not just theta. So cosine of 2 theta minus pi over 2 equals -1. Okay, so cosine is my x coordinate. I'm trying to figure out where's my x coordinate -1. That happens here. That's the angle pi. So I know that my argument must be equal to pi plus any full revolution to get us back to pi. And now let's slowly take care of this. Let's get theta by itself. So I'm going to add pi over 2 to both sides. So if I add pi over 2 to both sides, I can put that pi that's on the right side together with pi over 2. I can get a common denominator between those two. And that gives me 3 pi over 2. So when I add pi over 2 here and add pi over 2 here, I get 3 pi over 2 and plus 2 pi k. And then I divide by 2. So theta is 3 pi over 4. And then the 2's cancel on the next one. So I just get pi k. I get a common denominator here. And I get that. Let me see. I think I just had someone come to my door. Hold on. Yes, I did. Hold on a second. Okay, where was I here? Okay, so I have the general solution. Now I need to start checking values of k. So if we let k be 0, we get 3 pi over 4, which is definitely less than 2 pi. If k is 1, we get 7 pi over 4, which is definitely less than 2 pi. If k is 2, we get 8, 9, 10, 11 pi over 4, and that is bigger than 2 pi because 11 over 4 is bigger than 2. Let me just check. If k is -1, we will get negative pi over 4, and that's negative, so I can't use that. So it looks like just two answers, 3 pi over 4 and 7 pi over 4. Okay. Another one. All right, so tangent of theta over 2 plus pi over 4 must equal 1. Okay, so where is the tangent function 1 on the unit circle? So tangent is your y coordinate divided by your x coordinate. And the only time that those are exactly the same, so that when you divide, you get 1, would be here, and then directly across from it right here. And so that's, since they're directly across from one another, I can just do this angle here, which is pi over 4, and then just add half rotations. So I take my argument and I set the argument, the whole thing, equal to pi over 4 plus pi k, half rotations. Subtract pi over 4 from both sides and it goes away. That's nice. Theta over 2 equals pi k. And then I just multiply both sides by 2 and I get 2 pi k. All right, now just start plugging in values of k. So if k is 0, I get 0. If k is 1, I get 2 pi. But remember, we're supposed to be smaller than 2 pi, so I can stop here. This is not included. If k is -1, then of course we get -2 pi, and that's a negative number, so you can't have that. So we only have one answer. The answer is 0. All right, for this one's a little different. Solve the equation, give the general form for all solutions, then list all the solutions for k equals 1, 2, 3, 4, 0, 1, 2, 3, 4, and 5. Okay. So tangent theta, notice it's theta, right? Oh, you know what? I'm going to have to take this. Okay, so tangent theta has to be equal to -√3. All right, so we are going to look now. Our argument's just theta, so we don't have to worry about any sort of weird things happening here. All right, so where is tangent -√3? This is not a common number, but you have to remember this is the y coordinate divided by the x coordinate. So where would this happen? Well, it's a negative number, so it can't happen in the first or the third quadrant. Yeah, because that's where tangent's positive. So it'd have to be in the second or the fourth. So let's see, if we're here the x coordinate is -1/2, the y coordinate is √3 over 2. If I take the y coordinate and divide it by the x coordinate, then we will get the -√3, because you'll flip. This will become 2 over -1, then the 2's cancel, we get -√3. So that's where it occurs. And then it would also happen down here, because down here you have +1/2 and -√3 over 2. So if you do the same y over x, you get the same math happen here with that negative sign, you get -√3. So it looks like it's happening here at 2 pi over 3 and then directly across from it. So I know that my theta must be 2 pi over 3 plus any half rotation to get me back here. So I'm going to type this in. They'll probably take the general solution without a common denominator. Let's see. 2 pi over 3 plus, I'm going to write pi times k. I'm going to see how it does with this. Yeah, it did it. Okay, good. Now it wants the answers for k equals 0. So now I am going to get the common denominator, just make my life easier. So 2 pi plus 3 pi k over 3. And now if k is 0, we get 2 pi over 3. If k is 1, we get 5 pi over 3. If k is 2, we get 6, 7, 8 pi over 3. And what you'll notice is that every time we do this, the numerator is jumping up by 3. So it went from 2 to 5, 5 to 8. So we jump up by 3 again, it'll be 11 pi over 3. That's for k equals 3. For k equals 4, it'll be 14 pi over 3. For k equals 5, it'll be 3 more, 17 pi over 3. So let's try those answers. We have 2 pi over 3, comma, 5 pi over 3, comma, 8 pi over 3, comma, 11 pi over 3, 14 pi over 3, and 17 pi over 3. All right. See, I do better when it's daytime. Okay, cosine of 2 theta, our argument is something other than theta, equals √3 over 2. Okay, they say, give the general solution, find the general, and then list 6 solutions. So we know cosine is the x coordinate. We want to know when that is √3 over 2. That will happen here and here. And those are not directly across from one another. So I'm going to have 2 answers here. So 2 theta must be equal to, let's do the first one. It's pi over 6 plus 2 pi k. And the other answer is 11 pi over 6 plus 2 pi k. All right, so that's these 2 angles. And then now let's divide everything by 2 on, let me do this one. So to divide everything by 2, you get pi over 12 plus pi k. And on this one, if we divide by 2, you get 11 pi over 12 plus pi k. All right, now I'm curious here because we have 2 answers here for the general. How are they going to want us to do this? Is it going to let me put in 2 answers? I don't know if it's going to. Okay, pi over 12. I'm not going to get a common denominator yet, plus pi times k. Okay. What about the other answer? Now, yeah, it turns out those give you the same answers, but you wouldn't know that. That's a little tricky. Well, look, here's the thing. On a test, this is what I'm going to be looking for, these 2. So don't worry. The computer, there's a little limitation here on what the computer can handle. All right, let's do. Oh, okay, I see what they're doing. They're having the two different cases. Okay, here's where they want it. I got it. So now the larger angle. So it was 11 pi over 12 plus pi times k. I got it. Okay, now list the first 6 solutions that are greater than or equal to 0. The first 6. So let's get a common denominator over here. So this would be pi plus 12 pi k over 12. This one would be 11 pi plus 12 pi k over 12. All right, let's just start letting k be 0. We get pi over 12 and 11 pi over 12. That's what we get when we let k be 0 here. If k is 1, I get 13 pi over 12. And then on the other one, if I let k be 1, I have 23 pi over 12. Okay, they want 6 solutions. So let k be 2, that's 24 plus 1, that's 25 pi over 12. And if I let k be 2, here's 24, 26. I'm at 24. Is that right? Hold on. When k was 1, well, that's 23. When k is 2 is 24, 30, 35, sorry, 35. What did I say? 35 pi over 12. Okay, that should be it. That should be the first 6. Let's go for it. Pi over 12. And then 11 pi over 12. And then 13 pi over 12. And then 23 pi over 12. Oh. And then 25 pi over 12. And finally 35 pi over 12. Yay. All right, give general solutions, last 6 solutions. Okay, here we go. Let's 6 solutions. Sine of theta over 2 equals root 2 over 2. So where is sine equal to root 2 over 2? Well, sine, and that's the y coordinate. That's going to be here and here. So we got that theta over 2 has to be that first one, which is pi over 4, and then we have to get all the way back around to it. And then we could also have theta over 2 equals the other one, which is 3 pi over 4, and then we have to get all the way back around to it, so 2 pi k. And if I multiply both sides by 2 here, I get theta equals, let's see, pi over 2 plus 4 pi k. I'm going to need the common denominator, so I may as well do it now. Multiply 2 on the top and bottom there on that 4 pi k. And over here, if I multiply both sides by 2, I get 6 pi over 12, which turns out to be 3 pi over 2 over 2. And then plus 4 pi k. Multiply that thing by 2 on top and bottom, so 3 pi plus 8 pi k all over 2. All right, let's put this in here. I'm curious, will it take 3 pi in parentheses 3 pi plus 8 pi times k over 2? I wonder if it'll take that. And then on oops, sorry, that was the wrong one. I should put pi there. And then on this one, do 3 pi plus 8 pi times 8 pi times k over 2. Let's see if it takes that. It don't like that. And so I'm just curious now. Is it because I got a common denominator? Pi over 2 plus 4 pi k, that's this. 3 pi over 2 plus 4 pi k. So it did not like having the common denominator. Interesting. I mean, it's correct. It's just the computer's not smart enough to know it's the same answer. That's kind of ridiculous. All right, what now? Am I done? Continue. Oh, answers now. So if we want answers, let's see, if k is 0, we get, if k is 0, we get pi over 2, and on the other one, we get 3 pi over 2. If k is 1, we get 9 pi over 2, and then we get 11 pi over 2. If k is 2, we get 1617 pi over 2. And the other one, 16, 17, 18, 19 pi over 2. I'm kind of bummed out that it didn't take my answers on that previous one. Pi over 2. 3 pi over 2. 9 pi over 2. 11 pi over 2. 17 pi over 2. And one more, 19 pi over 2. All right. All right. All right, so secant theta, so check this out. This is what I said in class that we didn't get a chance to do. So it says use a calculator to solve this problem. Secant theta equals negative 4.9. So this means that cosine theta is equal to the reciprocal of this. The reciprocal of this is 1. I'll put negative 1 over 4.9. I'll do it that way. Now on my calculator, what I'm going to do now is I'm going to use the inverse cosine function. So I'm going to say that theta must be equal to inverse cosine, or r cosine, of negative 1 over 4.9. And I'm going to make sure I'm in radian mode. So I'm going to do inverse cosine of negative 1 over 4.9. And I get theta must be 1.776. Now, I need to make sure you understand what this means. What this means is that my angle, okay, 1.776. Remember, pi is about 3.14, okay, 3.14. So to say that theta must be 1.76, it's smaller than pi, okay? But let's see, what about pi over 2? If I take pi and divide that by 2, I get 1.571. So this angle that I'm getting, theta, is actually 1.7 something. So that's going to be a little bit bigger than pi over 2. It's like somewhere around here. And so what we're saying is that cosine of that angle, right? Cosine of that angle, 1.776, remember that's in radians, is equal to negative 1 over 4.9. Now, cosine is the x coordinate. So what we're saying is that at that angle, we have this x coordinate, right? Whatever it is. Then what we have to recognize is that we also should have that same answer down here. This will also have the same x coordinate. So although we know that this angle here is 1.776, we still need to figure out what this angle here is, all right? So the way we do that is, how can I explain this? If this right here from here to here is also 1.776, but negative because it's going backwards, what we can do is imagine doing this, going all the way around to here, that angle, but then taking away, so going backwards by this negative 1.66 or negative 1.776. So if we went all the way around, that would be 2 pi, and then we subtract from that 1.776. So I'll do that on my calculator. So let me see here. 2 pi minus 1.776. I get about 4.507. Okay, so I have 2 angle answers. I have this one and I have this one. So let's see, round to 2 decimal places. Let's see if it takes us. First one, I'm going to go 1.78, and then the other one, I'm going to round that to 0.51. Okay, it took it. So the tricky part of this problem is that when you use the inverse trig function, it only gives you one of the 2 answers. You have to look at the geometry of the problem to figure out the other one. All right, so this one, use a calculator to determine the solution. So 5 tangent theta plus 9 equals 0. So I will move the 9 to the other side. And then I'll divide both sides by 5. I'll just do that on my calculator. Negative 9 divided by 5 is going to be tangent theta is negative 1.8. Now, theta, I'm going to do the inverse trig function. The inverse tangent of negative 1.8. I do that on my calculator. And inverse tangent of negative 1.8 will give me an angle, theta, is negative 1.063. Okay, so the angle, if we look at this, remember, inverse tangent was only defined in the first and fourth quadrants. It's giving me an answer of negative 1 point something. So negative means I'm rotating clockwise. So my angle is somewhere in here. This is negative 1.063. And what we're saying is if whatever this X and Y coordinate is, if you take the Y coordinate and divide it by the X, you're going to get this number here. Well, there's another place that that's going to happen. It's going to happen directly across from it over in this quadrant because tangent's negative here also. So we got tangent can be negative there and there. So we need to figure out what that angle is from here to here. All right. And also, you know what? They want this angle here. They want that angle as a positive angle. So we need to figure out that angle also from here to here. So let me do the outside one first. You know what? I'm going to change that color. I'll do this outside one. I'll do it dotted. Okay. So I need to figure out what that angle is. So all the way around would have been 2 pi, but then I'm going to take away this 1.06, and that should give me this angle right here. So 2 pi was the whole revolution. I'm going to take away from that 1.06. So that angle is 5.223. And then to find this angle here, if we know that this value here is negative 1.063, that would be equal to this value. So what we would do is we say, okay, what happens if we go from here to here? That's pi. But then we want to take away this angle here, which is the 1.063. So I'm going to do that on my calculator. I get about 2.078. Okay, I think I might have had some rounding error in here. Okay, so this is going to be, I lost them, 5 point round to nearest 2 decimal places, 5.22. Comment, and the other one we said was 2.08. Okay, you took it, good. All right, I'm going to have to stop right now because of time. Well, you know what? I don't want to stop yet. I just don't want to do any more of these calculator problems. I want to get to the, yeah, this is what I want to get to. Okay, I need to pause it real quick. Okay, so for this one, we are going to, hold on a second. I have a little bit of problems here. Okay, so for this one, we've got 2 sine squared theta minus sine theta minus 1 equals 0. Did one like this, very, very close to this in class. We are going to view this as looking like a quadratic equation. And so we can factor it just the way we would factor something like 2x squared minus x minus 1 equals 0. So that would factor 2x, let's see, x minus 1 plus 1 here. I think we did this in class. Might have been cosine though. Okay, so 2 sine theta plus 1 and then sine theta minus 1. Let's double check. 2x squared minus 2x. Yeah, this is right. Okay, now we have 2 equations. Set them both equal to 0. And then this one is sine theta minus 1 is 0. So here we get sine theta is -1/2, and here sine theta is 1. Now, because our argument's theta, we can be very, very loose about this and just look at our solutions on the unit circle. Sine is -1/2 at, sine is the y coordinate, so it's going to be here and also here. That's 7 pi over 6 and 11 pi over 6. And then sine is 1, that's the y coordinate is 1 up here at the top, that's pi over 2. So we should have between 0 and 2 pi, we should have 3 solutions. They are going to be pi over 2, 7 pi over 6, and 11 pi over 6. What? Did I factor wrong? What happened here? Copy it wrong. Sine's the y coordinate. What did I do? Sine is negative 11 pi over 6, 7 pi over 6. Oh, I forgot a comma. What a pain in the butt. Okay, clear? All right, so now solving the equation cotangent theta plus 1 times cosecant theta minus 1 must equal 0. So it's already factored, which is great. We can just set each factor equal to 0. So the first one says cotangent of theta equals -1, which really means tangent, the reciprocal, must be the reciprocal of -1, which is still itself -1. This one says cosecant theta is +1, but that means that sine theta, that's the reciprocal of cosecant, must be the reciprocal of 1, which is also 1. So on our unit circle, again, because our argument is just theta, I just need to know where is tangent -1. We've done this a few times now. This is going to happen here and here. And then sine is 1, that's the y coordinate is 1 straight up. So we have pi over 2. This is 3 pi over 4, and this is 7 pi over 4. So those are going to be our 3 solutions here. 3 pi over 4. And then 7 pi over 4. All right. And somewhere here. All right, this one looks nice. Sine squared theta equals 5 cosine of negative theta plus 1. Okay, like that. Okay, so we have a cosine of negative theta here. We have a sine of theta squared. First thing I'm gonna do is use a Pythagorean identity to get everything in terms of cosine. So this turns into 1 minus cosine squared theta. We did that in class using the Pythagorean identity. I'm gonna distribute the 5 here and here. So I'm gonna get 5 cosine of negative theta plus 5. And then I'm going to use a very important property here that we talked about earlier in the class. The fact that cosine of theta is equal to cosine of negative theta is equal to cosine of theta. And that's because cosine is an even function. Refer back to your notes in that for that. So that means I can just replace that with just cosine theta, which is nice, because now everything is in terms of cosine theta, not negative theta here. And this is a quadratic, so I'm going to bring everything to the right side. We get 0 here equals, let's see, when I bring the cosine squared over, it becomes positive. I'm going to have the 5 cosine theta there. And then I had to subtract 1 on both sides, so that gives me +4. And now this looks like a quadratic. It looks like x squared plus 5x plus 4. And that's going to factor. This would factor to be x plus 4x plus 1. So this is going to be cosine theta plus 4, cosine theta plus 1. And now I set each of those equal to 0. Cosine of theta equals -4. And I set that one to 0. I get cosine of theta is -1. Now this first one can never be true because the cosine function is bounded between -1 and 1. So there's no solution to this. And then on this one, cosine is the x coordinate. And so the only place that the x-coordinate is -1 is here at pi. And they want the solutions only on 0 to pi. So I should just have one answer. Pi. All right. 4 cosine theta equals -4 square root of 3 sine of negative theta. Okay. All right, so there's a couple of ways to do this. First thing I'm going to do is I'm going to use the fact that sine of negative theta is equal to negative sine of theta, and that's using the odd property of sine. So when I replace this with negative sine of theta, I'll have times out here -4 root 3 equals this side 4 cosine theta. Okay, the negative and the negative there on the right become positive. So you have 4/3 sine theta equals 4 cosine theta. Now I'm going to do something very interesting. Because I have no real way, there's no Pythagorean identity I can use here to get this, the cosine to turn to sine or the sine to turn to cosine. What I'm going to do instead is I'm going to divide both sides by cosine theta, and you'll see why in a second. I get 4 here, and then 4, I keep doing that, 4 root 3, and then sine divided by cosine is tangent, so that's just tangent theta. And now I'll divide both sides by 4 root 3. 4's cancel over here, I get 1 over root 3. Then over here, I just have tangent theta. So the question is, where on the unit circle is my y-coordinate divided by the x-coordinate root 3, 1 over root 3? So I know I can't be here because tangent's negative there. Let me see. I'm going to try this one right here. This is root 3 over 2 and then 1/2. If I take the y-coordinate and divide it by the x-coordinate, that's the same as taking the y-coordinate and multiplying by the reciprocal. 2's cancel out. There it is. I get 1 over root 3. So that happened here. That's at pi over 6, but it would also happen right here. You can check for yourself. That's negative root 3 over 2 and negative 1/2. And so if I take this and divide it by this, the negative over negative is positive, and then it basically becomes the same computation as this. So that is the angle, what is that? 7 pi over 6. So I have pi over 6 and 7 pi over 6. Okay, moving right along here. I'm actually happy. I'm going to finish this. 2 plus 2 sine theta equals 4 cosine squared theta. All right, I'm going to try and get everything in terms of sine because here we have cosine squared. I can use the Pythagorean identity there. That cosine squared theta turns into 1 minus sine squared theta. Keep in mind, again, it's 4 times this, so this 4 has to go in front of this with parentheses because this is 2 terms. So we got this now. Distribute the 4. Let's move everything to the left side. Okay, so that came over, became positive. This is still here, and then I subtracted 4 on both sides, so I get -2 equals 0. And now I'm going to try and factor this. This looks like 4x squared plus 2x minus 2 equals 0, right? I can divide through everything by 2 first. That'll make it a little easier to look at. 2x squared plus x minus 1 equals 0. I can do the same thing over here. So 2 sine squared theta plus sine theta minus 1 equals 0. All right, now this should factor, hopefully. This should be 2x, x plus 1 minus 1 here. Yep, that works. And so this becomes 2 sine theta minus 1, and then sine theta plus 1 equals 0. Set each of those equal to 0. I'm just going to save us some time. Sine theta is 1/2, and the other one is Sine theta is -1. Okay, because our argument is theta, I can just look at the unit circle. Sine's the y coordinate. It's a half here and here. That's pi over 6 and 5 pi over 6. And then the y coordinate is -1 down here. So that's 3 pi over 2. Pi over 6, 5 pi over 6. 3 solutions. Pi over 6, 5 pi over 6, and 3 pi over 2. Jeez, okay. So for this one, 6 sine squared theta plus 13 sine theta plus 7 equals 0. That looks a lot like 6x squared plus 13x plus 7 equals 0. So let's see if we can't get this thing to factor. Let me see, I'm going to try this. We got 6x here, x. Let me go with 1 and 7 like that, and plus and plus. So here we get 6x squared. Okay, then 6x and 7x, that's 13x, and then 7 times 1 is 7. So yeah, that works. So this becomes 6 sine theta plus 7. And then it becomes sine theta plus 1 equals 0. Set them both equal to 0. So this becomes sine theta, check for yourself, just do the arithmetic, is -7 over 6. And this one is sine theta is -1. Now this will not have a solution because -7 over 6 is bigger than 1. Sorry, bigger than -1. So we can't get this to ever come out of the sine function. So there's no solution here. Yeah, so when I say bigger than -1, what I mean is this. Here's -1, -7 over 6 is over here. So we need to be between, sine needs to be between -1 and 1. So we can't be out there. So there's no solution here. This one, where's the y coordinate -1? Right there, 3 pi over 2. So we have one solution, 3 pi over 2, over 2. Okay, getting close, getting close. All right, so now we have 10 parentheses, 1 minus cosine theta, and then sine squared theta. Okay, distribute the 10. And then on the other side, I'm going to use the Pythagorean identity to get everything in terms of cosine. Move all my cosines over to one side. Okay, I have a 10 here. I'm going to subtract 1, so I'm going to have plus 9. Okay, that looks like x squared minus 10x plus 9 equals 0. And that should factor to be x minus 9, x minus 1 equals 0. So I get, I can just solve these here. This would be 9 and this would be 1. So x is the cosine. So this becomes cosine theta is 9. Cosine theta is 1. This can't happen because cosine is bounded between -1 and 1. Cosine is 1 here at 0 degrees and not 2 pi, because remember up here it says less than 2 pi, so 0. Last one. Okay, what are the zeros of this function on the interval 0 to pi? So they're saying take this function and what are its zeros? So set it equal to 0. So we're just solving an equation. So cosine squared x, move the 4 over 8, cosine squared x equals 4. Divide both sides by 8, you get a half. And so now you take the square roots, you get cosine x equals plus or minus the square root of half, which is plus or minus square root of 1 is 1, square root of 2 is root 2. And then rationalize the denominator so that we can recognize what this is. Plus or minus root 2 over, let's see, root 2 times root 2 is just going to be 2. And that we should recognize. So cosine of something is this on our unit circle. Cosine is the x coordinate. Here it's positive root 2 over 2 is the x coordinate. Here it's negative root 2 over 2. Here it's negative root 2 over 2. And here it's positive root 2 over 2. So at all these corner points, And notice that for this, I can jump from here to here, that's pi over 4. And then I can just keep jumping by 90 degrees, by pi over 2, pi over 2, pi over 2, pi over 2. So my general solution here is that the argument x must be the starting point, pi over 4, plus jumps by 90 degrees, or by pi over 2, so pi over 2k. I'm going to get a common denominator. So this would be 2 pi k over the common denominator 4. So I just had to multiply top and bottom here by 2, and that k is up on top. So we get this. So let's just start plugging in values of k, and our answers have to be between 0 and 2 pi. So if k is 0, we get pi over 4, which is definitely between 0 and 2 pi. K equals 1, we get 3 pi over 4. If k equals 2, we get, if k is 2, we get 5 pi over 4, which is still less than 2 pi. If k equals 3, we get 7 pi over 4. Still less than 2 pi. If k is 4, we get 9 pi over 4. And now we've gotten too big. And if you try -1, it won't work. So we will have 4 solutions here. I'm so excited. I'm almost done. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right. That is it. Done. Good, good. Right? I'm done? Yeah. All right. Hope that helps.